Good morning to all. So today class I will be discussing about how to calculate the vibrational modes in the IR spectrum. So the question used to come calculate the number of normal modes of vibration of an naphthalene. Before discussing these questions, I just give a brief idea about what is mean by vibrational modes, how to calculate that. First, in order to see the vibrational modes of a molecule, first of all we have to see the total degrees of freedom. So here for every atom the degrees of freedom can be calculated between the three axes, so that is called XYZ coordinates. So for an atom it is used to have 3 degrees of freedom. For an atom it is having a 3 degrees of freedom. If a molecule, if you consider this is having a n number of atoms, so 3n degrees of freedom used to have. So for a molecule, if n atoms it is consisting, so 3n degrees of freedom. If the molecule is a linear molecule, then it used to say that is a 3n degrees of freedom is a contribution of translational plus rotational plus vibrational degrees of freedom. Out of these, the rotational degrees of freedom in along with one axis do not cause any change. So that is the reason you can consider rather than 3 here 2. So translational 3 and vibrational degrees of freedom. So the vibrational degrees of freedom for a linear molecule, you can write it as the vibrational degrees of freedom for a linear, you can write it as 3n minus 5. This is the formula we are using to calculate the number of vibrational modes for a linear molecule. For example, if the molecule is non-linear, as usual, we will consider all as 3. This is also rotational, also 3. So for a non-linear, the vibrational degrees of freedom, you will write it as a 3n minus 6. So let us see the solved questions regarding this topic. The first question is the number of normal modes of vibrations in naphthalene is. Naphthalene, as we know, the 2 rings are not in one plane, one is above, another is below. So that was the reason that are non-planar molecule. If you draw a naphthalene molecule, so this is a naphthalene molecule here. So as it is a non-linear, so you can consider the formula, that is a 3n minus 6. So here the naphthalene is totally consisting 18 atoms here. So the total number of atoms n is 18. So minus 6, if you consider, it is coming, it is a 54 minus 6, the answer will become as 48. So option C is the right option. So the second question, the number of vibrational modes of CO2 is. CO2, as we all of us know, CO2 is a linear molecule. So for a linear molecule, the formula you can write it as a 3n minus 5. So if you apply the formula 3n minus 5 for CO2, you will get the option 4, because 3n is here, total 3. Minus 5, so 9 minus 5, which is equals to 4. Similar way, find the number of vibrational modes for the ethyl alcohol. Ethyl alcohol is also a non-linear molecule where you can consider the total number of atoms present here is 9. You can consider 3n minus, it is a non-linear, 3n minus 6. So 27 minus 6, which is equals to 21. So option A will be the right answer. But remember here, sometimes the question they are asking, out of all the vibrational modes like 21, all need not to be IR active. There are certain, some are IR inactive. So we have to look carefully the question. If suppose they are asking, write particularly the IR active vibrational modes will be discussed in the next class. So here the number of vibrational modes for NH3 also same. This is a pyramidal, so which is a non-linear. So you can consider 3n minus 6. So n is written as 4 minus 6, so which is equals to 6. So option A will be the right answer. So in this way, if just they are asking a number of normal modes of vibration, we can calculate the vibrational modes in the IR spectrum. Thanks for watching this video.